Alright guys, welcome back. Today is April 15th, and what we're going to be doing is working on problems 11 and 12 in this packet for adding and subtracting rational expressions with unlike denominators, especially when we see those denominators having polynomials or binomials. At the end of yesterday's video, I said you could try these couple problems out if you wanted me to go over them today. If you still haven't done that, or if you still want to try them out before you see me go over them, you can pause the video here and then hit play again, because I'm going to start working out these problems. So we'll look at number 11 first. If you recall from yesterday, what I said is that at the beginning of this problem, we solely want to look at the denominator. That's really the only place we're going to focus on for the beginning of this, because our goal is to get these denominators the same, then we'll mess with the numerators later on, after we've already combined them. But we're just looking at the denominators alone right now. And I'm going to factor the denominators in any way possible. So when I look at the denominator on the left, I see a polynomial. I can't factor it out because these don't have anything in common, but I can box method it. And if I box method it, what I end up getting is x plus 3 times x plus 2. Now, whenever I see that this denominator on the left has these two binomial parts, and I compare it to the denominator on the right, which is just x plus 2, then I realize this side is missing something. It is missing this entire binomial. It's missing an x plus 3. My goal here is to make the denominators match, make them the same. So if I can identify exactly what a denominator is missing, then I can multiply that in, or kind of add it in a way. So that's what I'm going to do on this side. Since this side is missing x plus 3, then that's what I'm going to throw in, or multiply in, to this side of the equation. And I think my pen is dying, so I'm going to swap those out. So I'm going to multiply these two. I'm going to get 1 times x plus 3, so that 1 is just going to distribute in, keeping it the same. I mean, multiplying something by 1 doesn't change a fraction or anything, right? So we have x plus 3 over our denominator x plus 2 times x plus 3. I know a lot of you guys might be looking at that and saying, well, do we FOIL it? You know, they are multiplying. Should we go ahead and do that? And in this case, no. We've already factored it out. We've simplified as much as possible. We want to keep it in that simplified form. Now, this side doesn't have to change, right? Because this is the one that already had the x plus 2 that this side had, but it had an additional x plus 3, which is why we multiplied that in over here. So this side didn't have to change at all. We didn't have to multiply anything in there. So it remains x plus 2, x plus 3, with x squared minus 5 in the numerator. All right, so we are ready to add these two fractions. As you recall, whenever you add rational expressions, denominators stay the same. So we're just going to combine terms in our numerator. We have an x squared here. We have a single x to go after that from right here. And then we have a minus 5 plus 3, so that's going to end up minus 2. This is going to be over x plus 2, x plus 3. Like I said at the beginning of the video, we only want to deal with the denominators for this opening portion of the problem. For us, combining it into one fraction, we only wanted to look at denominators in terms of simplifying, factoring, that kind of thing. Now that we have it into a single fraction, we've come to the point where we want to look at that numerator and simplify and factor it. So again, when I look at that, I can't factor anything out of this. They don't have anything in common amongst all three terms, but we are able to box method that. So if you box method this, then you end up with, let's see, factors of negative 2 that add up to 1. That would be x plus 2 times x minus 1. And then this is over x plus 2, x plus 3. And ultimately what we find is we have some redundancies in the numerator and denominator, x plus 2, that we can cancel out, leaving us with just x minus 1 over x plus 3 as our final answer. That is the combined form of these two rational expressions. All right, so we're also going to work on number 12. Like I said a minute ago, I want to look at the denominators. I want to simplify them as much as possible. Whenever I look at this one on the left, I see that this is a difference of squares problem. Both of these are perfect squares and they are subtracting. So I can break this side of the function down into m plus 2 and m minus 2. And then this side of the function, I notice its denominator only has m minus 2. Now that's in simplest form. There's no changing m minus 2. But when we look at the other side of it, we notice this side also has an m minus 2, but it has something else. It has m plus 2. So this is a situation where we need to notice what else this denominator has, m plus 2 in this case, and add it to this side. And I use the term add very loosely because technically we are multiplying it into that side. But we do need to make it to where m plus 2 is on the right-hand side of this expression as well. In the numerator, we're going to distribute 2 times m plus 2. 2 times m is going to give us 2m. 2 times 2 will give us 4. And then in the denominator, we have m plus 2 times m minus 2. We'll go ahead and add these. In our numerator, we have a couple of things to be able to combine. M squared doesn't have anything to combine with. It's our only squared term. But we have 5m and 2m that is together going to make 7m. And we have 6 and 4 that will make 10. The denominator will stay m plus 2, m minus 2. And now that we have combined these into a single term, single fraction, single rational expression, whatever you want to call it, we can look at the numerator to simplify it through box methoding. M squared plus 7m plus 10 will simplify into m plus 5 times, I ran out of room there. I'll write it down here. I also was using x instead of m, and m plus 5 and then m plus 2. Those are our two factors for that polynomial. The denominator is m plus 2, m minus 2. We have similarities. We have an m plus 2 in both the top and the bottom of this. So we are left with solely m plus 5 over m minus 2 as our final answer. All right. Those are going to be our two problems for today. Tomorrow we're going to keep on working throughout the rest of this. And then after tomorrow I may have a couple problems that I have you guys try out for a little bit and see if you're able to work on independently, see how that goes. If you have any questions about this, feel free to email me, let me know. Otherwise, see you guys tomorrow.